Hey everybody, Dr. A here, and in this example, we're going to be exploring another thin wall pressure vessel. So given to us, we are being asked to compute the required thickness of a spherical gas tank that has an inner radius of 60 inches and it's subject to an internal pressure of 150 psi. And we're also told that the maximum axial stress that the shell material can support is 18 ksi. So under solution, the first thing I'm going to write is sigma L max is 18 ksi. So that means that the maximum longitudinal or axial stress that the material can sustain is 18 ksi. And we're going to say, since that's the maximum, we're going to say that that's bigger than or equal to PR sub I over 2 times the thickness, okay? So if you remember, for spherical vessels, the main stress that it's got to support is longitudinal or axial stress. So we're going to set that maximum value as larger or equal to the governing equation, PR sub I over 2t. And then we can solve for the thickness, t, as being bigger than or equal to PR sub I over 2 times sigma L max. And of course, we know all these values. P is 150 psi, so to be consistent with our units, I'm going to call that 0.15 ksi. The inner radius is 60 inches, and we're going to divide that by 2 times 18 ksi. Okay, and then we can solve for this in our calculators, and I'm going to punch this in my TI 36X Pro calculator, and I'm going to get the following. I'm going to get 0.25 inches. Now, you can track the units pretty quickly. You have KSI and KSI cancel, so you're left with units of inches. So what this is saying is that our wall thickness must be bigger than or equal to 0.25 inches or 1/4 of an inch, which is fine. Now, we just need to check that with this thickness, we still have a thin wall pressure vessel, so we can always check R sub I over the thickness. That's 60 inches over 0.25 inches. And so 60 divided by 0.25 is 240, which is much bigger than 10. So it's still a thin wall pressure vessel. So our final answer is going to be a thickness of 1/4 of an inch. If you found this video helpful, please hit like and subscribe.